Hello badasses! This video will contain an overview of the player controller I've written and serve as an introduction to using Unity's built-in Animator as a tool for state machines. Let's get started. First, we should make sure that we have our project open with the following components. We'll need a player with a collider, rigid body, an animator, and that's about it. We're going to disable this for right now, as we'll be using our own scripts later. Now that we've set this up, let's take a look at the animator window for the player object. Let's remove these for right now. Now that we've removed everything, I'm going to add a few parameters to this animator, which is what my code will look for to handle these animations. Of course, if you're using your own code, you'll add whatever parameters are the same as you name them. We need 3 floats. These are basically numbers with decimals. We'll have move horizontal for horizontal movement, move vertical for vertical movement, and move magnitude, which just represents if we're moving at all. Now, we'll also need 2 bools, or true and false switches, or on and off switches. We'll call this one is jumping, and another is attacking. Awesome. Now, these values will stay the same unless there's some script to change it. Let's go to our player and add in player anim controller. This script basically gets the animator and will be setting these values. For example, move horizontal and move vertical are set to the input axes. The input axes basically represent W, A, S, and D, up, down, left, or right, or a joystick movement by default. If you want to see what these special buttons, input axes, jump, and fire 1 are, you can go into your project settings and check the input field. See? Left, right, A, D, W, S, down, up. And it will also handle controller input. So now that we have this attached to the player, let's try and move. I can't move. But wait, if we look up here, the values for move horizontal, move vertical, and move magnitude are changing. This means that this script is working. But why aren't we moving? Again, let's take a look at player anim controller. Well, all we're doing is setting animator values, but the animator isn't changing the state we're in. Now, I'll let you in a secret. Having a single script for a player controller may seem convenient, but it can lead to a bunch of bugs and headaches, especially when there may be no way to control when a player can perform an action without creating a bunch of if statements, booleans, or switches. Also, if you have a lot of animations, just setting up the animations in the script can be a headache. One way to fix this is to create a state machine, where we can only perform actions if certain conditions are met. Conveniently, that's just like how the animator works. Do you know what idea I have? Why don't we just use the animator as our state machine, controlling what we can do and when we can do it. Let's add a new state. We'll call it idle. We'll add in our idle motion here. And if you look here, we have an add behavior button right here. If we click this, we can add a new script, but I'm going to add in my player idle behavior. Now, if we look at this script, everything's commented out. It doesn't really do anything. You'll have onState enter and onState update. They're basically the same as Unity's start and Unity's update, but these only take place in the frame in which they're called. Let's try a print statement here, and we'll do debug log update idle state. Now, let's try running this. Let's take a look at this console. Whoa! We started idle state, but we're updating the idle state every call, just like start and update. Now I'm going to undo my changes for now. Cool. So we have a little bit of an overlook as to how these state machine behavior functions will all work. But we don't have any other states except idle, so we can't walk. To make our lives simpler, I'm going to create a blend tree. We'll call this blend tree walking. Now, blend trees are kind of like animation folders, but really fancy. You can have multiple motions handled by one blend tree, which means you can transition from multiple animations without having to draw lines for every single directional movement. For example, you don't have to connect everything to walking up, down, left, and right. Very convenient. Let's change the blend tree to look for 2 parameters instead of 1. We'll look for move horizontal and move vertical, since those represent what the axis is looking for. We can add our motions right here. I'll add our walks. Cool. Now you might notice that there's position X and position Y here. Our position X right now is move horizontal and our position Y is move vertical. Our up movement, or in case walk W, should be set to 0 on X and 1 on Y. Likewise, left should be -1 and 0. Down should be 0 and -1. And right should be 1 and 0. You can see these are all evenly spaced out. Now, we still have to connect our idle state to the walking state. And we can make a transition to this. And the cool thing about the blend tree is this is the only one we have to make. One to the walking state and one back to idle. Let's make sure has exit time is unchecked for our use. And we'll do it if move magnitude is greater than 0. Move magnitude, just as we saw before, represents if you're moving at all. And likewise, we can have move magnitude less than 0.001. We can't do equals 0, so this is as good as we can get. Now, let's try walking. Well, we're in the walking state, but just the animation's playing. We're not moving. Well, we have to add a behavior. I'll add player walk behavior, and we can preview how it works. Like before, on start from the game object that the animator is attached to. And during update, we translate or move the player transform in the direction which we set above, which is from the input get axis. And we normalize it so that walking diagonally is not faster than moving horizontal or vertically. Now, let's try this out. Cool. We can walk in all of the directions we need. Oops, I made a mistake. Real quickly, I had to fix a mistake. I forgot that S is down and D is right. I had these values flipped. Now, let's go back, playing. Cool. We can walk in 4 directions, and if we move diagonally, we can move in a number of directions. We can even get full 360 movement if we plug in a joystick right now. A bit difficult to do with arrow keys. We have clean transitions between idle and all of the walking states. Awesome. So now we're only playing the walking animation when we're actually walking, and the blend tree turns us around when we move to idle. To make this look even cleaner, we could add a blend tree for idle with multiple directions, and even diagonal animations. Now let's take a look at player jump. This one's a little bit more complicated, because we still want to be able to move while we're jumping, so the movement from before is here, but it's called as a function. And on start, we get the transform, we set an acceleration to the jump acceleration, and we say that we're not on the ground anymore, because we started jumping. Now, if we're on the ground, we'll set jumping to false, because we're no longer jumping if we're on the ground. And while we're jumping, we're going to change the player's position based off of the acceleration, and we're going to decrease the acceleration by gravity. This means that when the acceleration is negative, the player will start to fall. Now, let's add a jumping state, and we'll add the jumping behavior. Now, we also need to make a transition to jump. Making a transition to jump is easy, because the only condition we need is if we're jumping. But away from jumping is more complicated. Not only do we want to not be jumping anymore, but we also want to have move magnitude to go to walking, and we want to have move magnitude less than 0.1 for going back. Now to make sure we can see the actual jumping, or the change on the z-axis for the player, we need to make sure the projection type on the camera is perspective, and that our field of view is somewhat manageable. Now let's try and jump. Whoa! The player actually comes closer to the camera. Now, this looks a bit janky because there's not actually an animation on the jumping state. If we'd add one, it would look a lot smoother, especially if we had some sort of directional thing going on. You can also move on and add the player attack behavior to a new attack state, and add the attack script to the player from the combat system folder, but this will be for another video. I hope that these scripts inspire you to use the Animator to handle your states. The Animator is also very helpful for when we're going to be looking at enemy AI. Even if you don't decide to use these scripts, I hope you've had a good introduction to blend trees in Unity. I can't wait to see what you've come up with. As always, feel free to look at the links in the description before. Also, make sure to smash that like button, comment, and subscribe.